So let's have a look and see how we might go about answering this question. So let's remind you, we have a function for the height of water in a harbour, right? I don't really need to outline that or highlight that, should I say, but sure, we might as well. And my h of t, that's going to be my height of the water, and it's given by 2 sine in brackets pi over 6t plus 3. Okay, so let's have a look and see what we're being asked. The first thing we're asked is we're being asked to determine the maximum height. Okay, now look at, there's plenty of different ways about going after this question. I prefer to look at these from what I'd call a logical point of view. I'm going to use my basic function of sine, and I'm going to work things out in relation to that. Okay, so there's a few things that I know about sine, right? Sine, the period of sine, right, from the beginning to when it starts to repeat itself is given by 2 pi. Okay, full rotation, 2 pi, 360 degrees. Another thing I know is that the maximum that it achieves is 1, and the minimum that it achieves is -1. And then I can work things out, like whatever the period on my function, I know that I'm going to be at the midpoint at the beginning. I'm going to be at the midpoint halfway through my period. And then so if I'm looking for my highest point, it's a quarter of the way through the period, and my lowest point then 3/4 of the way through my period. So if I'm determining the max height of the water in this harbour, that's going to happen when this part here, when sine of pi over 6 t, when that whole thing is equal to 1, okay? Now, this pi over 6t, that changes the period, it changes the time that everything happens, but I know that the maximum that sine is going to be on its own is going to be 1, okay? So my max, where sine of pi over 6t is equal to 1. Therefore, my max is given by, it's going to be given by 2 times 1. All right, my maximum, this is my maximum sine, right? The maximum value that I'm ever going to get for sine on its own is going to be a 1 here. So I know that it's going to be just, I'm putting in 1 instead of the sine pi over 6t. And so I'm just getting 2 times that plus 3. And therefore, my max is at 2 times 1 is 2 plus 3, 5 meters. Now, there's one point only going for that question, and you should be able to get through it quite quickly in that way. Now, the thing is, if you have any kind of a sense of how these periodic functions work, you will know that, like I said to you just there, the bit in here will only ever go on the y-axis from -1 to 1, and it's this 2 here and this plus 3, that's what's going to change the amplitude. The 2 will change the amplitude, change what your max and min are going to be in relation to each other. And then this 3 here at the end is going to lift the function up or bring it down if it was to be a negative. Okay, so that's my first part of that question, done and dusted, and I'm moving on to the second. So the second says to me, right, it says to me, determine 2 different values of the time t when the water is at its highest level. Do I have my highlighter? I don't. Here, I'll stick it back on again. Okay, I want 2 different values of the time t when the water is at its highest level. Okay, so we said, look, looking at again, I can get rid of this. This was for part A. Okay, we'll keep that graph, that diagram, that quick sketch. Okay, because that gives me very interesting information here about it. There's, I'll put in my period again. My period, this is all. Now, this is not, I've not drawn the function I was given. I've not drawn 2 sine pi over 6t plus 3. I've just drawn a basic sine t graph. This is just sine t, the basic. Okay. Now, I know that the maximum value happens at a quarter of the period. So what I'm going to have to do is I'm going to have to find some way of working out, well, what's my period? All right, and for that, we have this formula here from our formula books. I can just plonk it right there for you, right? And we can see this here, my B. All right, that's the bit. So look, here's my period. My period is equal to 2 pi over B. That means that B is equal to 2 pi over my period. Okay, now that's the bit. The B is the bit which is multiplied by T, right? So I know that my B is equal to pi over 6, okay? And that should also be equal to 2 pi over P. Now I'm looking to see what my period is here, right? And so let's see what that does. How can I manipulate this around in order that I get my period? So I want my period up on the top line. I'm going to do some cross multiplying there, all right? And I will end up with P coming up to the top, dividing across by pi. That will give me 2 pi over pi, right? I cross multiplied, I exchanged places, my P and my pi there. And the other thing that I'm going to do is I'm going to multiply both sides by 6. That's going to bring that 6 up as well. And so we're going to multiply this whole thing by 6. So now I'm left with, this is just basic algebra that I'm doing here, right? I'm left with my P should be equal to 2 times pi times 6 over pi. A little bit of cancelling, nifty cancelling to be done. My pi cancels with my pi, and I'm left with P is equal to 6 times 2. And of course, 6 times 2 is 12. So I know that my new period, okay, of this function, now not a sine t, this is this function here, my period is actually going to be equal to 12, all right? And I know that my maximum happens in a quarter of the period, okay? So 1 max height will happen at 12 divided by 4, which is equal to 3 hours. Okay, now let's have a quick look at the question, see what kind of information they've given us. Can I define that as being a specific time or not? I don't think I have. T is just the time in hours. It doesn't say the time in hours after any particular moment. So basically, I'm going to have one of my max heights will happen at 3 hours after this experiment started. All right, now I'm asked for 2 values. Now we know this whole thing about a period, right? That means that this will continue on and it'll keep repeating every 12 hours. So if there was a high here at 3 hours, there will be another high here 12 hours later. So my second max at 3 plus 12 hours, okay, which is 15 hours. Now, that's all you need to be doing for that question. There's other ways of going about solving that, but to be absolutely honest with you, that is all you need in terms of answering that question. That's B done. B was worth 2 marks. We had two marks for B. We had 1 mark for A. And finally, moving on to C, they're asking you for a quick sketch on graph paper. Draw the graph of the function between 0 and 16 hours. What do we need to know for that? Okay, there's certain things that we could do with knowing for that, all right? And this is all, again, I'm looking at this all from the point of view of understanding my basic sine t function and then seeing what I can do. What on earth is going on with my pen at all? Tis making all sorts of weird stuff. Okay, hold on a second till I get that sorted out. All right, now she's going again. And here we go. So how can we adapt this? All right, so again, now this is really important. This is not to scale. Okay, that's for you. I'm doing it in this scale because it's all I have to work with, right? But they're very clear here. Look, I'll highlight it for you because they said it to you and you got to do it the way you're being asked to do it. Otherwise, you're going to lose the marks. They said use 1 centimeter for 1 hour on the x-axis and 1 centimeter for 1 meter on the y-axis. Now, I'm just going to use my boxes because, like I say, it's all I have. And I'm going to be looking at it from the point of view of this sine here. Now, what do I know about this sine function? There's a couple of things I know. I know that my amplitude has been doubled. Okay, so instead of going from 1 to -1 there, I'd be going from 2 to -2. That's my amplitude doubled. That's my 2 taken care of. The +3 means that I'm lifting this guy up. Instead of my max being at 2, my max will now be at 5. And instead of my min being at -2, my min will now be at -2 + 3, 1. Okay, so what that's going to do in effect with this guy is it's going to bring me up. So what do we say? We said that the max was going to be at 5. We said that the min was going to be at 1. And so my x-axis is now down there. Okay, this is just all I've left myself with my sine, my basic sine graph. And now I'm just filling in different details on it. We said that it would start repeating after 12 hours. Okay, so this is my full period. That's 12 hours there. That means I should expect to see this after 6 and this one after 3, we said. And so this is after 9. Now, clearly, I'm not using the boxes correctly. I'm just doing a quick sketch to see where I'm going to from there. I should get my next max should have been more or less at this point here, which is at 15. And so 16 is just after that. All right. So now if I was going to do this, that's just using the information from the question. All right. To try to ascertain or to manipulate my sine t graph into what it's going to look like. This is a quick sketch of what it needs to look like. Afterwards, of course, I'm now going to go and I'm going to draw it properly here. Okay, they asked me for 1 centimeter for each meter. So I know that here's where my min is going to be at 1, then plus 2, 3, 4, and 5. That's going to be my max there. And then what we're going to have is this is going to be my 3 hours. Then this is going to be 6. This is going to be 9. This is going to be 12. This is going to be 15. And I'm going to see where I finish up with right at the end over there. Translating all of this information here, right? I know that I'm starting at my midpoint, halfway between 5 and 1. That'd be 3. Okay. Get to the max after 3 hours. So I'd be there. At 6, I'm back to my midpoint. So here. At 9, I'm at my minimum. So I'm down to there. At 12, I'm back to my midpoint. I've done 1 full period of this graph. So filling in my details here or sketching in my graph. This is what we look like going along. 12, 15 is back to my max again. Okay. And then I'm going down the other side. Okay, I didn't do that quite well enough. Let's try again. Coming back up here because we want to be already going down. I know why that's not working because I've gone too high. Okay, I put my dot in the wrong place. My dot should be there. That's more like it. Okay, and we're coming up and then back down again after that dot. There we go. All right, so there you go. That's your last 2 marks for drawing the graph. Like I say, this guy here is still not to scale. I've used 1 box instead of 1 centimeter. When you're asked to use 1 centimeter, definitely use 1 centimeter. Okay. So guys, I hope you enjoyed that. If you found that a little bit complicated, like I say, I tend to teach these things looking at sort of an understanding model. How does it actually work? What's actually going on with it? All right. So try and watch the video maybe a couple of times to get your head around it if it was tough. All right. Otherwise, I hope you enjoyed the video and I look forward to seeing you soon. Good luck for now.